Hello, everyone. I'm Rupam Mahmood from Kindred AI, and we introduced the first set of benchmark learning tasks that can be easily downloaded and deployed on multiple robots to get effective and reliable learning. And we can all use these tasks to address the challenges of model-free reinforcement learning with physical robots. So what are these challenges? So we have seen several groundbreaking works of reinforcement learning on virtual environments, such as board games and simulated robotic tasks. And then a question arises naturally, why we do not see a lot of applications of the same algorithms, say, in the industry with physical robots? Now, of course, learning with physical robots, especially model-free reinforcement learning, is extremely difficult because of some of these commonly cited factors. And perhaps also the algorithms are not ready yet. But most importantly, we have learned recently that the learning performance can be highly sensitive to the variations in the experimental setup of both the hardware and the software. It is so sensitive that even if we use the same learning algorithm with the same randomization seed, depending on the setup, we can either get great learning as with the blue curve or no learning as with the red curve, which means that reproducibility is extremely difficult with physical robots if we do not share all the source code with all the details, or we do not know the right way of setting up a task, which I think partially answers why we do not have a lot of applications and what we can do as a community about it. To address this challenge, we introduced 6 benchmark learning tasks with 3 physical robots. And here we're looking at model-free learning directly with physical robots, starting from randomly initialized policies. These tasks range from reaching arbitrary targets by controlling the joints of an industrial arm on a moment-by-moment basis, to tracking, where we use an inexpensive servo motor, which any graduate student can easily purchase, to a robotic problem with a real and immediate application in the industry, where a mobile base is learning to dock to its charging station, as you can see here. Now, it's not just about making these tasks available. We also set them up the right way, which means that if we use the same learning algorithm with the same randomization seed multiple times, we get nearly the same learning curve, which is great. It means that reproducibility has become much easier, and learning performance is also more reliable. And we use these tasks to benchmark 4 different model-free reinforcement learning algorithms to see which ones are ready for applications. And they're extremely easy to use. This is from another lab. A PhD student from UTS STARS lab has already used one of these tasks to reproduce our results. And these tasks can be easily accessed from the open source project called SenseAct. SenseAct provides a toolkit for reproducible research with physical robots. And it also provides a step-by-step procedure to even develop new learning tasks the right way. And I would like to tell you more about it during the poster session. Thank you.